Who just popped in?
Me, I just came in,
Yep, I
Damaris.
got you. All right, looks like we're missing maybe 3 people or so, which is fine. All right, can everyone see my screen?
Yes, sir.
All right. And before we get started, how many of you went to campus to check in?
I know I did, sir.
All right. Ronald said he did. All right.
I did not. I can check in on next class if it's needed.
Well, it's on the first class of each week. If
Okay.
you don't need to, just let me know. That's one of those things that it's required if you are prior military or have any sort of title funding. But I will we can talk offline if we need to.
Okay, yeah, because I don't fall into in either one of those categories.
Yeah, we can talk offline.
Okay.
I'm checking in now.
Okay. All right. All right. So we've got just about everyone. And Justin, please don't go into the Columbia or into the Richland campus or Richmond campus, please. All right. So let's go ahead. So tonight, what I wanted to cover tonight's going to be a little bit, I don't want to say unorthodox, but it's going to be a little different than the way we did last week's first class. And the reason for that is this topic, chapter 6, is a dry slash hard topic. No matter if you have been working with databases for a day or if you've been working with them for 10 to 15 years. And I can say that because I was talking to another instructor slash a guy that I work with here in Columbia. We were talking about this specific topic and how I was going to deliver the topic. And his words to me were, yeah, good luck. And the reason for that is this particular topic, like I just said, it can be dry at times. And I won't say it's hard to understand, but sometimes it is sort of difficult to grasp. But I'm going to do my best to lay it out for you. I'm not going to go through a lot of the slides. I am going to talk through them a little bit, and I'm going to talk a little bit from what my experiences, and then I'm going to pull up Excel or Microsoft Excel, and we're going to kind of work through a little bit as well, just to give you an idea of what it is. All right. So some of the objectives that we're going to try and cover for tonight are what is normalization and what role does it play in database design? We're also going to talk about the levels of normalization or the forms, as you will hear it called, of normalization. You'll notice that there are 5 named here. You have first normal form, second normal form, third normal form, Boyce Codd normal form, and then fourth normal. There are more than that. And I'll even go a step farther and tell you that we probably won't even talk anything past third. So 1, 2, and 3. Simply because once you, and we'll get into it later on, but once you get into that third normalization or normalized factor, anything after that is merely adding to it. It's really partitioning things out that make it a little cleaner, but have no effect on the design itself. We're going to talk a little bit about how normal forms can be transformed from one form into another. So from first normal all the way up to third and even more. We're going to look at normalization and the entity relationship model. And we're going to talk about some situations that require a denormalization to generate information efficiently. So what is normalization? Normalization, in a nutshell, is the ability or the definition of evaluating and correcting table structures to minimize data redundancies. It also helps to reduce anomalies. Again, we talked about anomalies last week, insert, update, and delete anomalies. And it helps to assign attributes to tables based on determining factors or basic determining factors. And there are different types of forms that we want to cover: first, second, third, and fourth. You will see those represented from here on out as 1NF, 2NF, 3NF, even BCNF for Boyce Codd, and fourth normal form. When you are, let me go back, when you are in first normal form, when you have satisfied first normal form, you have removed what we call repeating groups. And we'll go into that in just a little bit. In order to satisfy second normal form, you have to satisfy first normal form. So you have to remove all the repeating groups first, and then you can try and satisfy second normal form, which is removing anything that is not functionally dependent on the unique identifier or that primary key. Then we get into third normalization. It gets a little tricky from here on out. To be in third normalization or to be in third normal form, you have to have satisfied first normal form and second normal form and be able to remove what we call transitive dependencies. Anything that does not have any correlation or any relation or a secondary relation to the primary key or the unique identifier. So like I said, once you get into that first and second, it makes a little more sense. You're breaking things out that makes sense to break out. When you start breaking that third normal form out, it gets a little bit more tricky. And I'm talking about breaking things out, but I haven't exactly dove in and told you what we're doing. Let's take the example that we used in week 1, which was a person, a student, a professor, or a class. We said early on that a student could be a person. So you could put all the information about a person in the student entity or in the student table. But does it really make sense to do that? That's what normalization gets you thinking about. Does it make sense? If I've already got the information or the columns, the attributes, somewhere else, why do I need to add them in more than one place? I can reference them by that primary key or the foreign key in the child table and be able to get the same information with the same amount of effort. And it'll start to make sense as we go a little deeper. The reason we normalize our databases is to make it structurally sound. A database table or a series of tables that are structured all the way up to third normal form are generally considered best practices in terms of database design. Now, I'm going to tell you all that, and I'll tell you most databases that you work with today, especially in a business setting, are already normalized. Most of them. There's going to be exceptions where you have what we call denormalized tables or denormalized structures. And those structures are anything that have to do with rapid data collection, uh, states that are not maintained for more than X number of minutes or hours or a small time frame. As an example, Facebook, Instagram, Twitter, TikTok, Snapchat, all of those styled systems or applications use more of a denormalized structure. They use what we would consider a no SQL approach, where they don't care what the structure of the system looks like as long as they can map the entities together properly. They don't care. It does increase your performance, but you have a much greater risk of data redundancy. But if you're not keeping it, if you're only using that as a staging table or a staging section, it really doesn't matter, which is what Facebook or any other social media platform generally uses it for, to quickly store information before they can transform it to long-term storage. So why do we need to normalize our databases? The need for normalization is used while designing a new database structure. It helps us to analyze those relationships between the attributes within each entity. And then it helps us also to determine if that structure needs any improvement or can be improved. And I'll go ahead and tell you, a lot of times it is subjective. Because if you have one person looking at a data structure, they may think it looks perfect. But if you have 2, 3, 4, 10 people looking at it, they may see things differently. And if you have 10 people in a room, you're probably going to get 10 different ideas. And that's okay, because any changes or any ideas on how to fix an application or a database are warranted, because some people may have ideas that one particular person may not have thought of. So what's the process for normalization? The objective is essentially to ensure that each table conforms to the concept of a well-formed relation or has well-formed relationships. So essentially, each table represents what we consider a single subject, a noun. So the person. The person can be defined as having a social security number, a first name, a last name, an address, a city, a state, a zip code, phone number, email address, gender, date of birth. Those make up that single subject. It's when you start adding things such as their department ID or the department they're in, their job title, their dependents information, their insurance information. All of those things, while they do help identify what a person does or is or can do, they do not directly affect the single person subject. So you would want to remove those. And so no data item will be unnecessarily stored in more than one place. And all non-attributes in a table are dependents on that primary key. So you should avoid putting anything in a table that is not related. You would also want to ensure that all tables, again, are in at least third normal form. Any higher forms are not likely to encounter anything that is related to a business environment. Like I said, once you get into Boyce Cod, 4th, 5th, 6th, 7th, 8th, all the way up, you start getting into more specialized database structures that have to be highly regimented. Most of your general databases flow around third normal form. So how do we start? We start by identifying the dependencies of each table. And then we progressively break those relationships down into smaller subsets of relationships. So if you want to look at the section where it talks about the forms, first normal form, or 1NF, removes repeating groups and helps to identify the primary key. Second normal form does everything in first normal and removes what we call functional or partial dependencies. The insurance information for a person, or the dependent information for the person, or the class schedule for that person may not be important for a person. So you would start to remove those things. And then you get into third normal form. Third normal form has to satisfy second normal form, which also has to satisfy first normal. And it removes what we call transitive dependencies, which is removing anything that is not transitively or in some way dependent on anything else in that table or that structure. And then you have boys cod and fourth. Boys cod removes determinants or candidate keys, anything that is not needed or could potentially be broken out into a secondary key or a secondary table. And then third removes independent multi-value dependencies. Like I said, you start getting into more specialized systems. And the higher you go, the more specialized it gets. All right, so before we dive into here, I want to break it out just a little bit farther. So there's other definitions of it, and I was trying my best a couple of hours ago to figure out the best way to explain normalization. And one of the things that stuck in my mind was trying to explain it to my 6-year-old. And while that wasn't probably not the best way to do it, I was talking to her about it and she kind of understood a little bit about what I was saying. So I'm going to try and modify it a little bit and change it, but I'm going to use it in a way that I hope it makes sense. Tell me afterwards if this makes sense to you. So let's imagine that you have, or your child or children have a large toy box. And so each toy has different parts. So it has wheels, colors, and shapes. And so now let's say we want to organize those toys so that you or the child can find them very easily. Database normalization is like organizing that particular toy box in a way that makes sense. Instead of keeping all those parts and pieces together in one place, it starts to group those into similar places. For example, all of the wheels go in one box, all of the colors go in another box, and all of the shapes go in a different one. And so, in a similar way, if we were to talk about databases, when we have tables of information, database normalization will help us organize that information into neat and efficient boxes. It's like making sure each box or the table has just what it needs and nothing extra. And so it makes it easier for us to find that particular issue or that particular toy, as it were, relatively easily and smoothly. Did that make sense?
Yeah, it made a lot. It made a lot more sense than everything.
Like I said, this is a dry subject.
Yeah, I agree. But
Let,
the explanation that you gave us, it was really good.
let me share my screen again. So, like I mentioned, we're going to probably be popping back and forth. And what I wanted to pop through this time is Microsoft Excel. And so I want to create a table, and we're going to break that table up. The first one is going to be denormalized. Denorm. And the second one is going to be, actually, we'll just do it all here. We're going to start off with fruit, if I can spell. Merge all those. And make it look nice. We're then going to have another section. We're going to call this one favorite. If I cannot spell. Favorite fruit. And then additional info. So we're going to break these down. I'm going to do it again, just to make them a little easier to read. And so our favorite fruit, we're going to say bananas and apples. And those are yellow and red. Our next favorite is grapes. And those are purple and small. Then we have watermelon and orange. And that's green and orange. If we were to take this particular table, and this table has 2 columns and 3 rows. So these columns are what we would consider our attributes. And this here is considered our entity. And our entity defines what the object is, and the attributes define all of its information, the adjectives that describe it. So a fruit can be a banana, an apple, a grape, a watermelon, or an orange. And it can have things such as, or be yellow, red, purple, small, green, or orange. And all of these are valid. And in a denormalized structure, they may make sense. However, if you start working with database normalization, there's a couple of things you have to start off by doing. The first is to put this particular table, I'm going to bold this and make it yellow. These are our columns that we need to change. You would want to remove what we call repeating groups. So how would we remove our repeating groups? Well, we would want to look at what would be considered a primary key. And if we only have two options, favorite fruit and additional info, which one do you think might be our primary key?
The favorite fruit.
Right, it would be the favorite fruit. That would be our primary key. Because it defines what we're doing or what we're trying to do to look at, right? So once we've defined what our primary key is, one key feature or one key thing you have to understand about primary keys is they cannot be duplicates. They have to always be unique. Well, while none of these are actually duplicates, you also want to remove anything that has a comma or a semicolon or anything that can be broken down into multiple objects. So what we would do first is remove those repeating groups. So I'm going to take this here and here. I'm going to remove all of these. So now that we have our list, we're going to just start breaking these apart. So we're going to say banana, apple, grapes, watermelon, and orange. Well, now we can break out that additional info because we know a banana is yellow, an apple is red, a grape can be purple, but it can also be small. So we're going to leave small there for now. And then a watermelon can be green, and an orange can be orange. So what we've done is we've taken our denormalized table of fruit and we've broken that out into a more manageable look and feel. We have added a primary key and we've removed any of those repeating groups, anything that's not going to be anything that doesn't that's repeating that's more than has more than one implementation or a comma. Right? Does that make sense?
Yes, it makes sense.
So let's
I
keep
do have a question. It makes sense. The only one that I'm a little confused on is the grapes,
purple and
where it's
small.
yes, sir.
Yep. That's a good point. So the reason purple and small are the same is in this row, in this particular setting, if there was a secondary fruit, so I don't know, trying to think of a fruit.
A kiwi.
Strawberries.
Kiwi. I should have used strawberry, but kiwi was the first thing I heard. Sorry. So if kiwi was in fact in this list, we would be breaking this out and say kiwi. small. But because this particular row did not have a comma in that primary key, it did not require us to break that out. It's just additional information.
Understood. And so because it's just additional information and the additional information in the second chart, we're only going by colors. Small doesn't fit on this key. Is that what you're saying?
Correct.
Okay.
Correct. All right, so that is first normal form. That helps us satisfy first normal form. Let's look at a second one. In this one, we're going to have books. So we're going to say books, and we're going to have a book ID, a title, and a genre. We're going to just do 1, 2, and 3. And we're also going to have author. Forgot author. So the title is going to, let's just say, Harry Potter. To Kill a Mockingbird. And give me another one. Sorry, I put you on the spot there.
Cat in the Hat.
Cat in the Hat. Okay. So genre is children's. I'm going to say fiction and fantasy. The author is going to be J.K. Rowling, Harper. Is it Harper Lee? Yeah, Harper Lee, and Dr. Seuss. Is that right?
Yes.
All right, so we have our books. I'm going to merge that.
What would be the primary key?
It's a good question. Anytime you're looking at a table and it has some sort of unique ID or generic identifier, I'm highlighting the book for a reason. That would be what we would consider the primary key or the primary ID.
Gotcha. Thank you.
And so to break this into first normal form, because technically it makes sense the way it looks, right? We've got a title, we've got a genre, we've got an author. Well, let's add one more to our list. Let's clear this out. And let's go with 4. And we're going to say The Hobbit. It's going to be fantasy, and it's by J.R.R. Tolkien. So now we've got 2 that are fantasy, 1 fiction, and 1 children's. Because we have 2 of the same in this list, while it is okay and it does work, and it would work for any of what we would need to do, it's not considered second normal form because it's not removing anything that's functionally dependent. The genre, while it is dependent, on where you classify the book. It's technically not dependent on the title or the author. I'm sorry, on the author itself. So what you would do is break books out into two tables. You would take books and you would get the title and the author, and you would break that out into the authors table. Numbers those three. And I'm going to do an author ID. And you would take your books and you would no longer need the author because the author has no bearing on the genre. So you would take your book and remove your author. And this will be your final product. You'd have your authors table and your books table.
So basically, if you have a duplicate in one of the, was it like the genre
Columns,
column? Yeah, in one of the columns, you just break it off from the rest of it.
if it makes sense to. Yes.
Okay.
And so in this example, what we're doing is we're taking the book ID, which is the primary key, and then we're taking the title and the genre, which seem to be dependent only on that book ID, and the author doesn't. So it is only dependent on the title itself. So you break out the book and the author into its own, or the genre and the author into their own. So you have your books by your genre, and then you would have your authors.
It makes sense, but I think it's still a little complicated to know how to divide and categorize each section, like authors and books, for
You're
example.
absolutely right. So, like I mentioned earlier, this particular setting, this first one here, would absolutely work. The
Yeah,
only reason you would break these up is if you really wanted to get nitpicky.
gotcha. I mean, the second one is what we would do at a real job, right?
You might would start to, yes. So let's take another one as an example.
Can we do like a real life example?
Mm-hmm. I won't do a real live example. I'm gonna do a employees and project. Does that make sense?
Mm-hmm.
All right, so I'm going to take what I've got. I've already gotten this kind of broken out and built a little bit. All right, so we've got a table. It's called the employees projects table. Each employee is assigned to a project, and each project has a department that it's working in. So you'll see employee 2 and employee 1 are both working on project A. And then employee 1 in HR is working on project B, and employee 3 is working on project B. While employee 2 is the only one working on project C. So in this particular example, you have employee ID and project ID. Both of those are what we would consider candidate keys, meaning they can break out into their own tables with little to no harm. The departments depends only on the employee. It has no bearing on the project itself. So what you would do or could do is break out the employee. So we'll say employees, spelled that, into employee ID, and the departments they work in. So 1, 2, and 3. And 3 is in HR, 2 is in finance, and 1 is in IT. And now that the department attribute is fully functionally dependent on its employee ID number, we can break out the projects themselves into project ID, project name, and employee ID attached to it. So 1, 1, 2, 2, 3. The project is project A, project B, A, and C. And then those employees are going to be 1, 1, 2, 2, and 3. So all we did was we broke out the department itself. And you're probably wondering why employee 2 is in the finance department, but employee 1 is in the IT department when clearly employee 1 works on IT and HR and employee 2 works on finance and IT. Well, the employee for 1 starts off in IT as their project, but then you'll notice that the project number 2 or 3 is the only one for the finance department. So it makes sense that employee 2 works in the finance department. And you can really change these out in any way, shape, or form. We would need to know a little bit more information around the employee's name, who they are, and what they do. Does that make sense?
Is it finance because ID has already been taken and it cannot be replicated?
Yes.
Okay.
Yep. Hold on one moment. Let's take a 10-minute break.
All right.
Yep. And I will be right back. All right, sorry about that. Is everyone still with me?
Yeah, I'm still here.
Yep. All right, sorry about that. All right, so that's really kind of what I wanted to talk through in terms of normalization. There's a couple other things we do want to quickly cover. So let me share my screen really quick. There's a way to document in Visio is what we're going to be doing today. It's to look at the dependency diagram for normalization. First normal, second normal, normal, third normal form. And what you'll see at the top here is it's a table that is considered denormalized or an unnormalized table. You'll notice it has the project number, the name, employee number, name, their job class, their hours charged, and then the hours itself. You also notice there are some arrows that break out each piece. Well, as you look through it, you'll see that they don't really all jive together. They don't all sort of fit that same mold. So what you would want to do is start to break these apart. You notice that employee number and project number are two different, or the same color, but are different than others. And they are underlined. The reason for that is they are considered the primary keys, or the candidates for primary key. You'll see that the project name, employee name, job class, charged hours, and hours are a different color. That's because they are considered attributes to this table. They do not have any full dependency or functional dependency on each other than the fact that they are in the same table. The only functional dependencies or partial dependencies that you see is the project number to the project name and the employee to, or the employee's number to the name, the class, and their charged hours. You then see maybe a transitive dependency between the class, the job class itself, and the charged hours, meaning those two could potentially be their own table. And so what you would then do in second normal form is break these up into three separate tables. You would have your first table, which is first or project, which is just your project number and the name of the project, the employee, along with its class and charged hours. And then you would have the assignment table where the employee is actually working on the assignment, where the project number and its employee number and the assigned hours for that project. And so in third normal form, we could even break that out even farther. We would say the project and the employee make sense to be their own two tables, but then that charged hours piece and the job class really don't make a whole lot of sense to be together in the employee's table. They're not transitively dependent on that job class or on the employee number. So you can break the job class out into the charged hours for that job. The job actually equates back to the employee number. So the employee is charging their hours. And then you would look at the project itself along with the employee, and see the assigned hours that the project is allotted per the employee. So we'll go back real quick, and you see we have this one massive table that has all of the information in it. And then we slowly start to break it apart until it fully makes sense. So let's look at it completed. We have our job name, or I'm sorry, our project, where we have 3 projects and the employee number. We have our job code, the description, and the charged hours for that job. And then we have all of the assignment number information. So the assignment, the date that it was assigned, the project, the employee, the assigned hours, the charged hours, and the assignment charged. So how much they've actually worked, how much they've actually charged for that job. Now you'll notice in this particular database, some of these attributes were not there originally. So there were some added, such as the assignment number, the assignment date. Those were added in to help solidify what that table is. Any questions on that so far?
I don't have any questions, but I'm still very lost.
Well, like I said, this particular example or topic is slightly confusing. And again, the best way I can describe it generally is putting things in a box or taking the toys and making it usable, right?
Right. But I think the hard part in understanding is how do you want to organize it? Like which things do you want to separate it by? And I think that's the hardest thing for me um, to understand.
And let's see, do we have any more that I want to go through to help? Don't yet,
Like
we don't.
the theory makes sense. I get that. But I just don't understand exactly like for example, like the things that we were doing just recently, how we're separating from books and authors or employees or projects. Like I don't know how to come up with the different separations for each thing. Like and especially now the pictures that you just showed us, um, it was very difficult to understand like how they come up with the idea of separating it.
All right, so let's see if I can't make this a little easier. I'm gonna pivot and see if this helps at all. I'm going to look at this in terms of a student and their classes.
I don't know if you're hosting your screen, like we can't see
I'm
it.
not. I'm
Okay.
not. Give me 1 second. It's actually going to show just the Excel spreadsheet. All right, so we're going to have a students table. And in that students table, we're going to have the student ID, name, their age, and their class ID. Actually, we're going to have class name and professor and class ID. So we're going to have all that in one table. So the first student, we're going to do 1, 2, 3, 4. This is going to be John Doe. He's going to be 18. We're going to have Jane Doe. She's going to be 19. Going to have Bob Roberts and Alice Lee. So 20 and let's just say 18. So their classes that they're going to be attached to are going to be 101, 10, 102, 101, and 103. Just trying to give some basic. 101 is math 101. 102 is going to be English 101 and history 101. Professors are going to be Dr. Johnson, Dr. Brown, Johnson, and Dr. White. So this is going to be our students table. If you had to take a look at this particular table, does it make sense to keep all of this together?
No, you can separate it by students and professors. And yeah,
Okay,
or
you
or
can. You're absolutely
You
right.
could
So
also break it down by students and class ID.
you could. So let's do both of those. I'm going to highlight the things that you just mentioned. So professors and class ID, right? So we've identified a couple of things right off the bat, right? And class ID and name, right? So the name would not be a part of this because the class name really doesn't define anything. Well, let's back up. We need to identify a primary key first, something that uniquely identifies a student. Which one of
student ID.
these? Yep, student ID would uniquely identify the student. Okay, so we've got our primary key. And because of that primary key, we know that the student has a name and they have an age, correct?
Yes.
So I'm going to mark those in yellow as well. I'm going to unmark these. Actually going to mark those in blue. And we know that a class ID is no good without a class name, right? So right off the bat, we can see that John is taking math. Jane is taking English, but Bob is also taking math. So Dr. Johnson is in here twice, along with math is in here twice. So we've identified that student ID is our primary key. Would we want to break, would class ID, does it have any bearing on a student whatsoever?
No.
No.
I think
Correct. So,
Oh.
so the class name and the professor really don't make a whole lot of sense to stay in this table, correct?
Correct.
So let's go ahead and remove those. this blue. And remove those. We still need to know that the student is in a certain class, right? But we don't need to know that the class itself, actually, we don't need to know all the information about the class. All we need to know is that the student itself is in a class. So we broke out the class ID, the professor, and the class name. By doing that, we now see a repeat of Dr. Johnson, correct?
Correct.
So we would remove that repeating portion, right? Because we wouldn't need it. You won't need it in there twice. So now we've got our student, their name and their age. We've got the classes that they're in. We've also got the class ID, which maps this class, which is taught by Dr. Johnson, which is Math 101, to how many students are in that class. Well, we know that that class has John and Bob. 102 has Jane, and 103 has Alice.
Okay, it's clicking for me now. So you took all the irrelevant information and just oversimplified it to say this is what this one chart means for the chart above.
Correct. We could even take it a step farther if we wanted to, because the class ID and the student, while it makes sense, does not necessarily have to be there. So this could be the classes table. We could, in theory, create a class roster table. I'll make this no fill. And this is going to have the student ID and the class ID. And so you would have 1, 2, 3, and 4, and 101, 102, 101, and 103. And now we can remove this. So now we have two independent tables, one for students, one for classes, but now we're pairing those two together. Because we have a student and a class. Does that make more sense?
Yes,
It does.
because
It does.
you combined the two tables into the third one. And so Joe, who has a student ID of 1, is in Mr. Dr. Johnson's math class 101 because of the class ID.
Correct. Correct. So that is truly what we did is we took the first section, which was adding all this together, which is unnormalized, and we broke it into two sections, students and classes. We then removed those repeating or redundant pieces of data, which was Dr. Johnson twice. And we further refined it by doing those pieces that put it into first normal form because it breaks it apart into two tables, and it removed repeating groups. The repeating groups was Dr. Johnson twice and the math twice. And then we went a step farther and removed the repeating column for class ID and broke that into its own, where a student can be a part of a class as the class roster. Because the class and the student, while they are partially dependent, they're not dependent enough to be in the same table. You could have a class ID with just that information along with the student, which is what we did here. All right, so let's take a 15-minute break. I've given you a 10-minute break, but let's take a 15-minute break. Go get something to eat, a glass of water, restroom, do what you need to do. When we get back, what I want us to do is go through the two guided practices, and I'll walk you through those, and then I will explain a little bit more about the project for part 2, and then I'll let you go for tonight. All right, so let's take about 15 minutes, and then we'll come back. All right.
Thank you, Professor.
Yep.
And the example made a lot more sense. Thank you. I appreciate it.
Okay. All right, sorry about that. Is everyone back?
Yes, sir.
All right, let's go ahead and minimize that screen. I'm trying to get to the ones that I need. Okay, so I'm going to pull this screen up and share it. Okay, so for tonight, we're going to go through two guided practices. The first one is looking at dependency diagrams, relational schemas, and then the ER diagram, and kind of putting all that together. And then the second one is looking at importing from Excel and then normalizing the database. So we're going to look at importing a Excel file into Microsoft Access and then sort of massaging it. The one thing I want you to remember or understand when we start looking at 2.3, and I'll go through that once we get there, is you do not have to have a working knowledge of Microsoft Access. In fact, what you'll need to do that guided practice, I'm going to walk you through. All right, so for 2.2, which is the first guided practice in this week, we're going to look at the dependency diagram. And so it has a set of instructions that we can use. I'm going to download those and open it. And then I'll share that. It also gives you a brief piece of information around what normalization is. It talks about first normal form, second normal form, and third normal form. And I do want to read through these really quick before we go into the guided practice. So first normal form has a series of steps. The first step lists all of the attributes in the database in one dependency diagram. All of them. Then it wants you to choose the appropriate primary key fields or values. Then compare those primary keys to the non-primary key fields to help you determine if a partial dependency exists. And then it wants you to keep in mind that every attribute must be partially dependent on a primary key. Then it wants you to compare all of those non-key attributes to other non-key attributes to see if any transitive dependencies exist between them. This is the case where one field cannot exist without the other. And then it wants you to draw arrows on those particular fields, identifying both partial or functional and transitive dependencies along with the dependency diagram. Then it wants you to list out the tables. Second normal form wants you to break all of those partial dependencies up into multiple tables. And then you will have the dependency diagram written out for those as well. And then third normal form wants you to break out the transitive dependencies, if any of those exist, into their own tables. All right, so I'm going to share this screen, this whole screen. All right, and the first thing, I'm going to make this larger, is the purpose of this exercise is to walk us through normalizing a table in a real world scenario and creating a dependency diagram and relational table schemas along the way, and then an ER diagram that will help be created for third normal form. So in this example, it wants to look at an unnormalized table or data set. We have gallery name, gallery owner, gallery phone. We have the painting number, the title, the price, the painter's number, the last name, the first name, and the phone number. All of this data is put together to form the gallery's information, the painting's information, and the painter's information. Right off the bat, you can probably tell that we have gallery, we have painting, and then we have painter. Those are the three tables right off the bat that we would want to see. So the first thing it wants us to do is open up Visual Studio. Now, if you have Visual Studio locally, you can use that. If you do not, you can use VCastle. And we're in VCastle too. If you need me to reset your password, just let me know. I can absolutely do that for you. Let's see, I believe. Okay, just want to make sure I wasn't missing something. All right, so I'm going to go ahead and go into VCastle. I'm going to launch VCastle. So I'll be doing everything from VCastle for this example. I'm going to move this file over to a new screen. First thing we'll do is open up Visio. And we're going to use crow's foot database notation. We'll keep it as US units. And then I'm going to make this larger where it's easier to see, if I can. All right, so the first thing it wants us to do is it wants us to create 10 boxes. Now, we can do that a couple of different ways. What I'm going to do is I'm going to create the boxes as we need them. I'm not going to do 10 all at one time. So I'm going to do insert design. Looking through, we'll go to home. I'll go to tools and rectangle. I'm going to create several here. And Isaiah, give me 1 second. I will reset yours. Let me go ahead and do that. I'm going to come out and reset his real fast. And then I'll pop back in. Interesting. Isaiah, I'm going to send that straight to you. All right. So we've got our first box. I'm going to go ahead and go inside of this box, and I'm going to type in gal num. I'm going to make that smaller. How about 6 font? So now I will copy the second one. We're going to call this one gal owner. Third one is going to be gal own. Fourth one is going to be painting number. painting title. You can see where this is gonna get long. Go ahead.
Professor, how did you make the paper longer?
Say that again.
How did you make the paper longer?
Oh, how did I make this longer here?
Yeah.
I'll show you. So what I ended up doing is you go down here to the width or zoom, and I just did 250. Because if you do standard, it's 100 and it's small.
You could also
250?
Yeah.
you could also use your scroll hit control and use
Yeah,
your scroll
that's what I'm
button
doing
to
there. Using the control and the scroll bar. Okay, then we have our painter. Number. L name. F name. And phone number. So the reason I did it that way, as opposed to doing 10 of them and breaking them out or putting them in a line, was it was easier for me to do the geometry of it and make it look more uniform this way, as opposed to doing 10 at one time and hoping that the titles would fit. All right, so now that we have all of our columns or all of our attributes, we need to identify what our primary keys or our unique identifiers might be. And based on what you see here, which one of these do you think would be the primary keys?
Galnum?
Galnum. Let's go painting.
PTANGNO.
Yeah,
PTR
yeah,
num.
painter
And
num,
then
painting number,
painter
and
num.
gallery. Yep.
Yeah.
And so we're going to take those and we're going to mark those as green. So I changed the shape and the style of those to green. That way they are broken out as primary keys. After we build our primary keys, we now want to build out our arrows to make these look like they match. So we're going to go over to our line fill, go to arrows, and I'm going to choose this arrow here, the third one. And we're going to choose relationship. And we will do the third one. I'm going to make these a little bit bolder as well. I'm going to make it 1 point. So we'll map this one there. And then we'll do the same thing. So I'll select it and do a Control C, Control V to copy it. And straight.
Professor, sorry, can you show us again how to get the arrows to pop up on the top?
Like this here?
Yeah, like the arrows that you have them.
Sure.
Yeah.
Sure. What I did was I went to relationship and drug that over.
Oh, okay.
I selected that relationship because I've got to do it again here. So I'll take that relationship. I went to line under shapes and styles, went to weight. I did 1 point, and then I went to arrow, and I chose the third one.
How much weight?
I just did 1 point.
Okay. And arrows, and you chose the third one. Okay.
Yep. Okay.
I don't know how to use Visio so much.
I don't use it much at all.
Do you actually use it in like real life jobs?
I don't. There are people in our company that do. There's actually one person who uses it very extensively when she
Really?
does diagrams and things like this, but she only uses it to do basic diagrams. And I'll show you one of hers in just a moment.
Okay. I'm trying to figure out how to connect the lines. I don't know how to do it. It's like showing up like little triangles and circles in between the lines.
Are you on
Relationship?
it? But are you using VCastle or using
No,
locally?
I'm using Visio on my computer.
Okay, give me 1 second. Let me finish these 4 out, and
Yeah.
then I'll let you show on your screen.
Okay. Thank you.
Yep. And I'll tell you, I've taught this class many, many times, and I've never gotten these things to look this way. They never come out this clean. All right. And then the last thing we would do here is do a text box for each of these. We'll call it partial tendencies. I'm going to make that smaller and change the color to black. And then we'll do the same for these 3, and these 4. All right, and Brizio, you want to share your screen now? This is the first part that I
Yeah.
wanted to show. So yeah, if you want to share your screen. There we go.
Can you see it?
Yep, it's coming up. Okay. And which part were you trying to do?
So I just need to know how to like connect the arrows between each.
Okay, you're fine. So go over to that relationship on the left-hand side. Drag that all the way over into the pane. Yep.
Oh, track.
Yep.
Oh,
Select it and go up to the line. Go down to weight. Yep, 1, and then line arrows, the third one. There you go. So you'll take the first portion and attach it to gal num. Yep. The second one to gal owner. Yep. And you do the
awesome.
same thing.
Thank you so much.
Yep. And then I will, let's see. I'll pause here for a moment because the next piece is just taking this and breaking it out. So I'll pause here for just a moment and let everybody catch up. Okay, so let's take the second part. So this is considered unnormalized, although we have taken the first steps. Before we marked it, it was considered unnormalized. Now that we've marked it, it's now considered first normal form. So I can do this here just to show you the progression. So we've got unnormalized, we've got first normal form. And now we want to break this out into second and third. And so the way we would do that is we'll select these, our first three here. We'll take our second three. Just one. And then our third three. And I noticed that one was missing. I'll bring this back just a little bit. So we went from an unnormalized to identifying our primary keys and our dependencies to breaking our tables out into our schema. Um, Alnum. All right, so my comma is not working. So I'll do the other way. Okay. Interesting. By the way, so I can do this because it's messing up on me at the moment. Text, gallery, gal gal owner, gal phone, Okay. Do the same thing here. Painting. Painting number. Painting title. Price. This one is painter. Painter number. L name. F name and phone. And so what I did there, and I'll zoom in on this one, is we broke it down into second and third normal form, and then we reiterated what the relational schema would be. So once you've got all three of those, and so that is, I'm going to come back out just a hair. So we've got unnormalized, first normal, and second normal form. We now want to go into Visio right below here, and we're going to create those entities that we were talking about. So we're going to pull all three of them over. And we've done this before. We're just going to do it again and show them in a little bit more stark contrast. So gallery. Gal num. So we'll add a couple more. Gal owner. Own. And then gal rate. We will say painting. And this one's going to have 5. Painting number. Painting title. Price. And that's going to have 2 foreign keys. One for the painter number. And then one for the gallery number. primary key. And then we have the painter. There's going to be 5 here as well. So our first one is going to be painter's number file name F name area code and then phone number. Okay, and so with these, we're going to bring the relationships over and have a painter to a painter. I'm going to make these larger. And here, I'll change the style on that one. Okay, and then we'll do another one over here. And it's reversed. So one gallery can have many paintings and one painter can be in many galleries. I'm sorry, one painter can have many paintings. All right, so that is the first guided practice. So just to recap real quick, we built our first unnormalized structure. We looked at partial dependencies on that, and then we broke it out into primary keys. And then the next portion is we broke it out into their own tables. And then lastly, we built our structures for crow's feet notation. Same thing here. Gonna be jumbo and jumbo. And so if you want to submit this using Visio, you're more than welcome to save your Visio diagram and upload that. Or if you want to take screenshots, you can take multiple screenshots. You can do it of just the ER diagram, which is this right here, and then of the normalization portion, or you can take screenshots of each one of these. It's perfectly up to you as long as you show each and every piece. Any questions on that so far? All right, so let's go ahead and I'm going to minimize this section. And I'm going to share my desktop. For this next assignment, what it wants us to do, or next guided practice, it wants us to download an Excel spreadsheet, which is this file here. So I'm going to download that. And make sure that's downloaded. And it is. Then it wants us to open this instruction sheet. And so in the instructions, we're going to be importing an Excel spreadsheet into an Access database, and then we're going to save that. So I want to walk you through those steps. Right, so I'll go to Start. I'll just type in Access. I have a Microsoft Access database, so I'll click on that. It wants us to create a blank database. So we'll click on blank right here at the top. Yours may look different. It may be a different color scheme. It may even be a different version. I'm using Microsoft Access, I believe it's 365. Yep, Office 365. So yours may look a little different than mine. That's perfectly fine. What you need to do is choose blank database. We're going to save this database as your last name underscore imports and normalization. And I'm going to save this in my downloads folder. And then you'll choose create. By default, you'll notice it opens up a new table. We're not going to worry about that at the moment. We're going to go up to external data, And before I get into that, I do want to mention that over the next couple of weeks, we will be going through each portion of Microsoft Access. So don't think that we're not going to cover some of this. I just want you to understand that what we're doing for this particular exercise is related only to importing external data and then manipulating it. Going forward, we will be working in the create portion and in the database tools portion. We'll talk about that later on this week and next. So we'll go into external data. Under external data, you should see in export grouping the Excel file button. Click on that. It's going to ask you to, I'm sorry, that's the export button. We want to import. We're going to choose new data source on the left, go to new file or from file, and we're going to choose Excel. We're going to be importing that file that we just downloaded. So I'll go to downloads and select that file and choose open. And we're going to import the source data into a new table. And we're just going to say OK. It's also going to say, is the first row or the first row contains some data that can't be used to validate the field names. In these cases, the wizard will automatically assign valid field names. That's perfectly fine. Go ahead and choose OK. You'll notice that we have several pieces of information. We have the orders, order details, order date, customer, book title, and then we have 2 extra fields on the end here. So we're going to choose next. I'm going to slide over here to our final 2, field 5. I'm going to choose do not import and field 6 and say do not import. So that way we do not import these 2 fields. So we will say next. It's going to ask us if we want a primary key. We're going to say no for now. And then we're going to choose next. We're going to call this table TBL book order 1 and choose finish. And it should be successful, and we'll say close. Now we should have a secondary table called table book order 1. If we open that, we should see our orders, our order date, our customer, and our book titles. The next thing we want to do is normalize this table. So we're going to create a brand new table. So we can take table 1 here and right click and say rename. Actually, we have to open it first. Cannot rename it while it's open, so I'll close it. We'll go over to create, to table. We'll click on the view over here on the left-hand side. We'll choose Design View. Again, we'll be looking at all of this later on in the next couple of weeks. We're going to call this TBL Book Orders 2 and hit OK. Rename. There we go. So in our first design, we're going to use order ID. That's going to be a number. Order date, customer, quantity, and title. We're also going to select this first one and delete it. And we'll save it. Okay. And so now we'll need to populate this. So order is D10 2019. Uptown Books 10 and Hog Wild over Ham. So I'm going to do this. Paste. And then all you do is slowly modify these to make it work. And you just keep going. So book number 2. Teen 2019 Book Mania. And all I'm doing is filling this out. I'm going to pause after I get it finished so that you can copy it. Kill cooking. Jamie's notebook. 7. Cookie magic. East Side News. 1-8. Dinners, quick lunches. Okay, so now that we've got all of that added in, and some of them may not match what shows in the text, that's perfectly fine. I just want to make sure that they look right here. So now we've got table 1 and table 2. To take that a step farther, we're going to copy. So right click and copy table 2 and then paste it. And we're going to rename that table 3. By doing that, we're also going to copy the data and the structure and say OK. So we'll take 3. And we're going to break this down into 2 more tables. So I'm sorry, 3 more tables. So book orders, bookstores, and then books. So we can break this down. Just building it out. Give me 1 second. I'll create a new one called TBL book stores. Go to design view. We'll call this book store ID and store name. Save that. Change this to Uptown Books. Book Mania. Amy's Book Nook. East Side News. Books and more. Bootman's. Millie's Bookshop. And University Bookshop. We're going to do another one for book titles. So we'll go to Create, New, Save, TBL Books, Design View, Book ID, and Book Title. So I'm going to take all of these titles. And I'm going to remove some of these. So we got ham, beanie weenies, sushi, braised cabbage, Crazy about cabbage. I'll delete that one. So now we've got 16 distinct numbers. And then we need one more called orders. And so the order details can actually take 3, rename 3 as table book orders. So we'll rename this and we will remove the customer, quantity, and the title. And we'll change that to book store ID. So that will be order number 1, 510, bookstore ID 2. All right, so now that we've got all of those created, and I'm going to upload this so you'll be able to see it. And you can use it that way you don't have to type out all of that. We'll go to file, options, current database. And if you hear somebody, that's my daughter. She's helping. Current database, and then select overlapping window. And then say OK. It's going to ask if you want to reopen it. We're going to say OK. Close all of these. And then as we open them, we should close that database and reopen it. And now we should be able to see them. Data sheet view for all of them. I'll open these. Okay. And so what we want to do is be able to see these. So you can take a screenshot of this here to see that it works. So now I'm going to go to File and to Save. Then I'm going to close this. It's going to ask if I want to save it. I want to say yes, that's fine. And then I'm going to go here and upload this to chat. That way you all can see that file and you can modify it as you need to. That way you don't have to worry about recreating it the whole way.
Picture.
So let me ask, does anyone have any questions on that portion? And I'll go ahead and tell you it beforehand. 2.3 is slightly difficult in a way until we get into Microsoft Access. So if you wanted to follow the steps that I did, that's perfectly fine. If at any point in time you have an issue with this portion of the guided practice, don't worry about it. Use the file that I just uploaded. Take a look at it, rename it to your name. Make sure you look at it so you kind of understand what I did, where it is, and then you can use that as your submission. I'm not too worried about this particular guided practice until we get into Microsoft Access next week. All right, so does anyone have any questions?
I don't have any questions, but I just want to say thank you.
All right, well, let me go ahead and stop the recording. Before I do that, I do want to mention I've gone through and graded everything except for the performance assessments for the last week and the project. I will be doing the project and the performance assessments tonight and tomorrow, so you'll see those tonight and tomorrow. And if no one has any questions or anything, then I will stop the recording and I will let you all go for the evening.
Thank you, Professor.
All right, let me stop the recording.
Have a good night.